Next, we're going to find the exact value of cosine of inverse cosine of the negative square root of 3 over 2. So if we go to our unit circle, right? Well, there's two possible values for negative 3 square root of 2 for cosine. It would be 5 pi over 6 or 7 pi over 6. But remember, our cosine needs to be between 0 and pi. So the inverse cosine of negative square root of 3 over 2 is 5 pi over 6. And I did all of this just using our unit circle. It's really super handy. Here are our property laws for composite functions for cosine. Remember, we really need to focus on the domains. So if I have cosine inverse of cosine, that's going to be when our possible domain, right? This is our domains, are between 0 and pi. Because that's us taking our cosine domain and restricting it for inverse cosine. If I have f inverse of x, which is inverse cosine of x, that's going to give us x, where negative 1 is less than or equal to x, or x is less than or equal to 1. So we're taking our domain, right, of cosine from negative 1 to x. That was our domain for this function, and we're intersecting it with the domain of cosine, which was before negative infinity to positive infinity. So we really just want to focus on our domains. I'm taking the cosine inverse of cosine of pi over 15. I need to make sure this is between 0 and 15, which it is. Go team. So that's just going to give, 0 and pi. So that's going to give me pi over 15. If I'm taking the cosine inverse of cosine of negative 3 pi over 4, again, I need to make sure this is between 0 and pi, which it is not. But, so let's talk about that. Negative 3 pi over 4 is not in the interval from 0 to pi. But, cosine is an even function. So cosine of negative 3 pi over 4 is the same as cosine of 3 pi over 4, which is in our interval from 0 to pi. So now I have cosine inverse of inverse cosine of negative 3 pi over 4, a positive 3 pi over 4. That's just going to give me 3 pi over 4 as my final answer. So let's take a look at the tangent function, right? Here's our tangent function. And what we're going to do in order to make this pass the vertical and horizontal line test is we're just going to look at an interval, and we're going to look at the interval from negative pi over 2 to pi over 2. And notice, though, that unlike with sine, these are not inclusive, right? It's less than. And that's because those points are asymptotes for our tangent function, right? So so for the tangent inverse function, my domain is all real numbers because that's the range for our tangent function. And the range for our inverse function goes from negative pi over 2 to pi over 2 because that was the domain of our original tangent function. So all my solutions are going to be in quadrants 1 or 2. So here is our inverse tangent function graphed with our tangent function. So if I want to take the inverse tangent of a negative square root of 3 over 3, I'm going to have to look at the unit circle and figure out, okay, where am I going to get negative 3 over 3? That's actually going to be at 11 pi over 6. And the reason it's at 11 pi over 6 is because at that point is where tangent of 11 pi over 6, that's the point where y is negative square root of 3 over 2 over 1, that's the point where y, I did the exact same thing in the real class. That's the point where y is 1/2 and x is the square root of 3 over 2. So I have 1/2 divided by 2 over the square root of 3, times 2 over the square root of 3. So I get 1 over the square root of 3, negative square root of 3. But we do not like radicals in our denominators, so I multiply that with the square root of 3 over the square root of 3. That gives me the square root of 3 over 3, but it's negative. So that's why that's the exact value for tangent. We also can take composite functions of tangent and inverse tangent. So f inverse of f of x equals tan inverse of tan of x, which equals x when pi is less than x or x is less than or equal to pi. That pi is negative. And f of f inverse of x, tangent of inverse tangent of x equals x when negative infinity is less than x, which is less than infinity. So that's the composite function rule for tangent. The next thing I want to do is find the inverse function of f of x equals 2 sine of x minus 1. And we're going to find the inverse function the exact same way we did for non-trigonometric functions, right? What we do is we switch x and y, and we solve for y. So if I have y equals 2 sine of x minus 1, we'll rewrite that as x equals 2 sine y minus 1. And we start by isolating our y, so we're going to add 1 to both sides. That gives me 2 sine of y. I'm going to divide both sides by 2. So I get x plus 1 over 2 equals sine of y. And then I take the sine inverse of both sides, right? Because by our composite rules, that's going to cancel out, but we're going to have to focus on our domains. So now I have f inverse of x is sine inverse of x plus 1 over 2. Now, we need to look at the domains and the ranges. Let's change colors. Let's look at the domain of our original function. Remember, now we're constricting it, so its domain would be from negative pi over 2 to pi over 2 inclusive, right? That now becomes our range for our inverse function. Also, we're now looking for our range of this function, but we have to keep in mind what's happened to this function. This isn't your standard sine function with a range from 1 to negative 1, right? This function has been amplified by 2, so what was 1 to negative 1 is now 2 to negative 2, but then it was also shifted down 1. So instead of being from 2 to negative 2, it's 1 to negative 3. So negative 3 to 1. So that becomes our new domain, which is negative 3 to 1. Last but certainly not least, let's solve an equation with an inverse function. And that is supposed to be a 1, a minus 1, not a minus 11. Sine to the negative 11 would be kind of scary. So we're going to start by dividing both sides by 12, because 12 is a coefficient. So I get sine inverse of x equals pi over 4. I'm then going to take the sine of both sides, because that's going to cancel out the inverse sine. So I have x equals the sine of pi over 4. Well, the sine of pi over 4 is the square root of 2 over 2. So x equals the square root of 2 over 2.